Okay, guys, am I audible properly? Can you see my video?
Yes, sir.
Okay. Am I audible properly, guys? Everyone?
Yeah, it's so clear.
Okay, fine, thanks. So, guys, today's topic is GRE. Okay, we'll be starting with the GRE encapsulation. In yesterday's class, I completed policy-based VPN. In today's class, we'll start with the GRE encapsulation. So understand guys, GRE stands for generic routing and encapsulation. It's a routing based VPN and it does the encapsulation. It does not do any encryption or a hashing. Okay. So GRE has its own protocol number. It's a 47 and it is defined by the RFC 2784. So if you go through this RFC, you'll come to know about the GRE protocol itself. So without wasting time, I'll directly take you guys to a practical and make you understand what is exactly a GRE, what's a role of GRE. So we'll get into a three different steps here. Okay, the first step would be we'll create a GRE tunnel. Second is with IPsec, and third is SVTI. Three things we'll see in today's class. Okay. So we'll see side to side VPN with the GRE. Okay, that's our first thing. Wait.
Sir,
Yep. Guys, please
hello.
mute. Yes.
How are you? You're fine.
Yes, I'm good, Mohammed. How about you?
Sir, yesterday I'm good. Yesterday you completed VPN between two sites, but
Correct.
we only show the results on Wireshark.
Correct. Mm-hmm.
Could you please check or inform us how to check it from the router side? What is the command used to check if everything is okay if we don't use Wireshark?
All right. I'll show in today's class then. Okay.
Okay, thank you.
Yeah. So guys, we'll see side to side VPN with the GRE. Okay. But it will be without IPsec. It's without IPsec. Then we'll see with IPsec, and then we'll see SVTI, and we'll also see some CLI verifications. Okay. All right. So these are the total tasks that we are going to do with the lab configuration, guys. So without wasting any time, let me directly take you to my lab. Most of the guys were interested in a class and they had actually connected with our sales team as well, guys. If you have any queries, questions, we have our sales team online with us. We have Ambud sir with us right now. So if you have any queries, questions regarding any type of admission or any type of courses, guys, you can ask questions or anything if you have any queries.
हेलो
Yep, tell me.
सर इस क्लास का वीडियो सेशन मिल जाएगी क्या?
ये सारे वीडियोस हमारे YouTube पे अभी लाइव आ रहे हैं, ठीक है, जाके देख सकते हो। अगर इसको और इन डेप्थ में समझना है, ठीक है, और इन डेप्थ में टेक्नोलॉजी को समझना है, तो हमारे ग्रुप, आर यू गाइस कनेक्टेड विद अ व्हाट्सएप ग्रुप? क्या हमारे व्हाट्सएप ग्रुप पे हो आप?
यस सर।
तो उसमें मैंने सारे डिटेल्स दे रखे हैं, हमारे सेल्स हेड वगैरह सारे टीम का नंबर उसमें दिया हुआ है। दो नंबर है जिस पे आप लोग कनेक्ट कर सकते हो, और कोर्सेस जो भी आप करना चाहो उसके रियल डिवाइसेस वगैरह पे जो भी प्रैक्टिकल्स हैं, जैसे नेक्स्ट वीक हम लोग पालो आल्टो फायरवॉल करने वाले हैं, ठीक है, जो कि लाइसेंस्ड फायरवॉल पे काम होने वाली है और लैब्स होंगे। तो उसके रिगार्डिंग अगर कुछ क्वेरीज वगैरह अगर हो तो डायरेक्टली आप लोग कांटेक्ट कर सकते हो. So guys, what I'm telling is, if you have any queries, any questions regarding admissions or any course, if you guys are looking for, you guys can connect with our sales team. We have given all the updates, all the contact details in a group itself. Okay. So if you guys are not connected with our WhatsApp group, please go through our YouTube channel as well. There we have all the updates. And so far, if you want to hear itself, I'll give you a link. Just give me a minute. I'll share the link with you guys. You can join our WhatsApp group. We'll be posting all our updates over there. So very new offers are going to come. So we'll be posting our new offers in a group. Okay. Our sales team will be updating you guys on that. Now, let me open my EVNG. So admin EV. Guys, we'll give you full support if you have any queries, questions regarding any labs, anything. We'll be giving you a full support. Okay. So you guys can reach out on our group. You guys can find me over there. Or if you put any queries in a group as well, I'll be replying back. Or else you guys can text me directly on my contact number. Okay. If you have any technical queries. So yesterday we completed site-to-site VPN between routers, which was policy based. Today we'll do a routing based VPN. Okay, using the two private IPs that will be communicating. A topology will remain same, but there will be an additional thing that which will be adding. GRE tunnel works. We have to use a virtual tunnel. So here I'll create a virtual tunnel, and I'll have a virtual tunnel subnet like 192.168. Hmm? Sorry guys, I guess there was some interruption. Okay, there was some interruption. I'm back now. So here 192.168.10.0/24 will be our subnet. Subnet for our virtual tunnel. Okay, from this tunnel, I'll create the tunnel interface. Tunnel interface, I would say. Let's say tunnel interface number 1. I'll take an IP address as a .1 and I'll place it here on this site. And as per the GRE rule, you guys need to have same subnet tunnel IP, okay, on the other side. So here I'll take .3 as an IP. So this is our tunnel subnet, guys. Now I'll quickly configure a notepad. Like I did yesterday, I'll create a notepad for you guys. So till your devices comes up, we'll do the configuration. We'll keep updating new type of free classes and many more offers. I request all of you guys to get connected to our WhatsApp group, guys. Is there anyone who is not a part of our WhatsApp group? So I'll take invitation from here. I have shared a Zoom chat. Kindly join this link, guys. You'll be connected to our free WhatsApp group where we'll be posting all the informations. Please get connected to this WhatsApp. Now, coming here, we'll first of all make a configuration of R1. Enable configure terminal host name R1. Interface Z0 by 0 with the IP address. We'll take public IP 100.1.1.10 with the mask of 24. No shirt. And here I'll create a loopback interface. Interface loopback 1 IP address 10.11.11.1 with the subnet mask of 24. And I'll later create a GRE tunnel. First of all, let me create a connectivity. Okay. IP route towards the ISP, I'll give a default route which is 100.1.1.2 IP. So I'll quickly take all this configuration. I'll put it on R1.
Hello, sir.
Yep.
Hello, sir. So
Yep.
in the real environment, so how can do the connectivity without configuring the VPN?
No, first of all, we have to make a connectivity, right? I haven't done any VPN configuration right now. Do you see, did I create any configuration regarding a VPN? First thing what I said is, see in yesterday's class also I told and today also I am telling you. The first thing is to make a connectivity. Whenever you want any VPN to create on any site, first of all, create a connectivity. Check a connectivity. If connectivity is good, then only go for a VPN configuration.
Yeah,
Okay.
I know that. I'm asking you in the real environment, in the real equipment, site 1 and site 2. So how to make the connectivity?
By doing
By default,
yeah,
Abdul, you will have the connectivity. You just need to make sure the public IP is pingable
your
from your router or firewall.
voice is not
If it is not,
voice
then you
is
have
not
to.
clear, Sudeep. There is some interruption in between. See, in a
I'm
real
saying
time, what I'm saying is, okay, let me answer his query. Yeah, let me answer. So in a real time, guys, you'll have a public IP, right? And public IP, you need to purchase from ISP and you'll have a connectivity through ISP itself. That's why I told, right, in a yesterday's class, if you guys have attended it, here I have what I told is, here you need to configure a public IP. Here also you need to configure a public IP. It will be a static public IP, not a dynamic public IP. So a connectivity will be done via ISP, not through your private IP or any other IP. So you have to purchase the IP from ISP and worldwide you'll have a connectivity.
Okay. So the connectivity should be between my router and the ISP side. Hello?
Abdul, basically you have to ping the IP, the public IP, the remote IP should be pingable from the device from where you are making the connectivity or the tunnel. So you will give a public IP to your device, and similarly, the remote IP, the remote device should also have a public IP from his ISP. So both of them are on the internet. So ideally, it should be pingable.
Okay. Fine. Okay.
Same thing I was telling. On both these sides, you need to have a public IP, which you'll have a connectivity via ISP. Okay, so you need to purchase this IP. It's not like you can use any public IP randomly without having, without purchasing it from the ISP. So make a connectivity, we'll have a route towards the ISP, and through ISP, both the public IPs should communicate with each other. So reachability, you can basically check with your ping command, right? Yep. Okay. So now here we have the other subnet G0 by 2 interface. You can configure it as a 200.1.1.2. So this is our ISP configuration, guys. I'll take it on our R2. See, if you keep attending the classes from beginning, right, you'll have all those informations. Like in a previous class also, I discussed same thing, how to make a connectivity. First, we need to have a connectivity between the two sites, right? So what is the use of public IP? Everything I had explained in our previous two theoretical classes. Okay, so here it comes with R3. R3, I have given 200.1.1.10 IP here at G0 by 0 interface on the R3. Loopback interface, which is our private IP, 172.16.10.3, I'll give an IP, and gateway will be 200.1.1.2. So what I did is I configured this IP from this particular subnet, 100 subnet, and I gave a default route. I created a loopback. Similarly, on the other router, I configured this interface from 200 subnet. I created a loopback. I created a default route, right? And after doing all this stuff, I'll quickly copy and paste the configuration. Okay. I'll take it on R3. Done. Now, the first thing, as I told you guys, connectivity part, I'll check a reachability from R3. We'll try to ping 100.1.1.10 IP, and yes, I'm able to reach. So either from R1 or R3, you should be able to reach both the public IPs. I was able to verify. So I was able to verify connectivity. Now we are good to go with our VPN configuration. So first of all, we'll configure a GRE tunnel. Understand guys, GRE tunnel does not have anything to do with IKEv1 or IKEv2. It does not have anything to do. IKEv1 or IKEv2, it's your choice what you want to implement over a GRE. Okay, so GRE configuration remains same no matter you go with IKEv1 or IKEv2. So here I'll tell you how to create a GRE tunnel, and we'll capture a packet and we'll see the entire information over here. So here I'll come to R1 and go to a configure terminal. Here I'll say interface tunnel 1 and IP address. Three things you guys have to configure here. IP address. So you have to give an IP address. So we decided to have this 192 IP, 192.168.10.1 IP with subnet mask of 24, right? And you have to give the second parameter is tunnel source. So tunnel source, I'll give it as a 100.1.1.10, and tunnel destination will be the other side's public IP, which is 200.1.1.10. And you guys will notice right now, as soon as I'll press enter, your tunnel interface status will come up. Okay. Oh, sorry, tunnel destination. Here I need to say tunnel destination. So give this IP and you see tunnel destination. Once I give, your tunnel interface has come up. Now do so running interface tunnel 1. So these are the parameters that I used right now to create a GRE tunnel, and this was on R1. So this configuration I did it on R1. Right. So once this configuration is done, GRE tunnel. Now once this is done, I'll take it for R3 as well. I'll take it for R3. I told you guys IP has to be from a same subnet. So tunnel source will be 200 dot 1.1.10 and destination IP will be 100. So I'll take this configuration, I'll put it on R3. Now, if you guys notice one thing here, if I don't give a tunnel destination, your tunnel status will not come up. Now, if I just give a tunnel source and if I check do so IP interface brief, you see tunnel interface status shows you down. But as soon as I configure tunnel destination, right, you'll see tunnel status will come up. And once it is up, now guys, though tunnel is there, I won't be able to communicate between these two loopbacks. A reason would be you don't have a route in a routing table. So both these sites, so IP route, if you see, I don't have a route. See, if packet goes through default route, it will go to ISP. I don't want my packet to go through ISP. I don't want this thing to happen. I want my packet to go through tunnel.
Tunnel.
So
Okay.
if I want my packet to go through tunnel, I don't see a static route over here or any dynamic routing protocol that will send a packet to 172 network. I don't see here. It means it will follow this default route and this default route will take a packet to a ISP. So now let's configure. I told you it's a routing based VPN. So in a routing table, I'll basically create a dynamic routing. So IP, EI, IP router, EIGRP. Okay. Router EIGRP, I'll give autonomous number as a 10 over here. And I would say network. I would add a network. What's my private networks here? Here I would say 192.168.10.0. And my other private network would be 10.11.11.0. And I would say no auto summary. Okay.
So,
So, yep.
why do you need to add 192 is already there? What is the requirement of adding this 192? Because we are putting it source and destination as a part of tunnel. So why do we want to advertise 192 network? Ideally, we need to only do the LAN part, which is the loopback we are representing here, right?
No. See, what we have to do is we need to advertise those private IP as well, right? So when I need to communicate, right, when I have to do a routing here, I need to advertise this private network so that they can form a neighborship. Now, if I don't give, they okay. See here, as per the rule, you have to go and configure the routing, and you have to do, let's say for example, if it forms a neighborship, it will communicate. If it does not form, there will be a problem. Okay. See, in order to tell your router that, hey, you need to send the packet through the tunnel, you need to have a route, you need to have a proper route. Okay. Now here, just check out here. If I give this command, right? Now let's say this command, I need to give it on the, let's say here. I give it on R1 here. Let me give it on the R3. See, the route which I have statically right now, it does not have a particular destination. Now here, if you, I mean, now so IP route, if you see, now I do have a, directly connected route over here, but if I try to communicate making a base of this particular destination, how will it understand that I need to go through a tunnel? It might take a path of your default route, right? It might take a path of your default route. So basically, I need to advertise it under the EIGRP so that it can understand that packet has to go through our tunnel. Right now, you'll see while connecting to this particular gateway, connecting to the other side loopback, it will make the other tunnel interface as a gateway. Now wait, let me go to other site. Here, if I come, And if I configure neighbor 172.16.10.0, and if I configure it, if I come here, if I go to the R3, now you see we have a neighborship with this particular IP. It says it formed a neighborship with whom? It formed a neighborship with my tunnel interface IP, right? Now if you see, so IP route here. Now if you see on a R3, it says, hey, if I want to communicate to 10 subnet, private subnet, it will send it via a gateway. Gateway is our tunnel interface of the other side. Similarly, if you want, see, it's a rule of your dynamic routing protocol, right? Whichever network you want to communicate with, you have to advertise your directly connected network, right? I believe you are aware of the dynamic routing protocol. How does it communicate? So you have to advertise it under the, it's a directly connected network, that's true, but it's not like you can communicate without advertising it under the dynamic routing protocol. So directly connected networks, whatever we have to advertise it under the dynamic routing protocol. So IP route, it's a basic rule of our routing. And now here, if you see the other side, if I want to reach the private subnet 172.16.10.0, I have a route of the other side interface, tunnel interface, and this is the timer running over here. So this proves that there are two paths now. I have two different paths. I have two different gateways. This is one gateway, which is our ISP, and we have another gateway, which is 192.168.10.3, which is our tunnel interface of the other side. So if any packet matches this source and this destination, then your router will understand I need to route a packet through this gateway. So it will go to a GRE. This is how GRE works.
Get router.
Sorry. Now here I'll capture a packet. I'll go to
Info
G0 by 0 interface.
table all. I don't see that IP here.
Guys, please mute. Madhuri, you can please mute. Now you guys can see here in an interview, you guys might get a question like if EIGRP neighborship is formed and if we have a multicast IP like 22.4.0.0.10, then how does the EIGRP communication happen when a GRE tunnel is communicating? So how does a EIGRP neighborship happen? Does it happen through your ISP or it happens through tunnel? This type of question you might get in an interview. So guys, you can see live here how EIGRP packets are passing. Now I clicked on one of the packet and here you see even your EIGRP communication is currently happening through EIGRP communication with this private source and a multicast IP, right? Is happening through GRE protocol. It is through the tunnel which is carried by public source and public destination. So that's how GRE is communicating. Now, since I have a GRE created a tunnel, I can ping to private network 172.16.10.3 with my source as a loopback 1. See, I can communicate and here I can see my packet. So this is my request and a reply. I tried communicating from one loop back to other loop back as a two different private networks of two different locations using a GRE protocol with a public source and a public destination. And I'm trying to communicate with your ICMP protocol. And here I have a ICMP core request that I can say in a packet. Type is 8, it means it's a ICMP core request. If type is 0, that is ICMP core reply. So if I click on reply, it should be 0. You can see it's a 0 over here. So guys, here we understood that yes, without IPsec also, I can communicate, I can create a tunnel, and it's without security. I can read the entire information. So your packets are not encrypted. So understand guys, whenever you are creating a tunnel between two different sites, tunnel does not mean a security. I created a tunnel right now, which means without IPsec also I can create a tunnel, right? But does it provide a security? Is a tunnel secure right now? Without IPsec, will it be secure? Answer is no, it won't be secure. So what we need to do, we need to create a IPsec, right? Now tell me guys, which IK version you guys want me to implement, IKv1 or IKv2?
True, true.
Two? Okay, let's go with
Yeah.
two then.
Yesterday we did for AKV1, right?
Yeah, yesterday we did with one. Okay, let's do with two today.
Yeah.
So let me directly take you guys to our notepad. Now here, first of all, I'll say crypto IKv2 and say proposal. Total 8 steps we'll be using, and give some name here. Like I'll give prop 1. Okay. Now, yesterday I told you guys, like we can give multiple algorithms for encryption, multiple algorithms for hashing. I told you in IKv2 on a Cisco router, it's possible. So let's say encryption. If I define here, okay, encryption. Sorry, my bad. Here I need to create a proposal, then I'll go with policy. Sorry. So first of all, I'll say crypto IKv2 proposal. I'm creating a proposal. I'll give a name prop1. Now it says IKv2 proposal must either have a set of cryptographic, encryption algorithm, right? And then it should have a Diffie-Hellman. So I should have at least one choice, or I can give multiple. So I'll say encryption. Now, if you press a question mark here, I have 3 days. I can go for 3 days. I have AES. If you press again a question mark, now 3 days it's used here, so it is not coming. I can go with AES. I can go with 192. It's up to me. I can define multiple algorithms. Now, let me complete one site. After that, I'll give you explanation for other site. So encryption. In IKv2, hash is represented as an integrity. So I can go with MD5, I can go with SHA-1, I can go with SHA-256, right? And I can go with a Diffie-Hellman group. I can go with 2, I can go with 14, I can go with 5, I can go with 14. It's up to me how I want to proceed. So this is proposal that I created. So let me add this proposal in a notepad, guys, quickly. So it's an IKEv2. I'm adding on R1 proposal. In a proposal, I added multiple encryption methods. I added multiple integrity method.
So this one we have to choose one, or you have to choose all.
No, you can go with one as well. Okay. I'm giving multiple here. The reason is, let's say if I have to communicate with multiple sites, right? And if the other site is using 3 days, also I can establish tunnel. If other site is using AES 128, still I can
Okay.
establish a tunnel. So
Okay.
basically
Okay.
you can understand on the headquarters site, I'm giving multiple
Okay.
proposal type of, preferences, right?
Yeah. Oh, I get you. I got the point.
Okay. So now step number 2 I'm creating. I'll create a crypto IKv2 policy. Give some policy name, like policy 1, I give a name. And here you have to say proposal. What was my proposal name? It was prop1. So you have to use it here. So let me copy this and paste it on R1. And you see, I created a policy. Now, step number 3, you have to say crypto IKv2 keyring. Now, like IKv1, we don't have a pre-shared key directly mentioned in a proposal. Here we have to separately create with the name of keyring, and here I'll say IKv2 keyring. So key ring KR, right? And I'll say my peer. My peer is R3. I'll say R3, and inside this I'll say address. What's my public IP? My public IP is 200.1.1.10, right, with subnet mask of 24, right? And here I'll say pre-shared key. Now pre-shared key, local followed by 0, I can write in a clear text. Followed by 0 means I can write in a clear text. Let's say Cisco 1. I wrote a password and I'll say pre-shared key. A remote, on a remote site, what will I write? Cisco 3. Okay, and I'll say exit. So that's how we created a keyring. So I'll quickly take this command. I created a keyring. Inside a keyring, I defined a peer. Inside a peer, again, I
So
defined, yeah,
can you write down the step 1, 2, like yesterday? Just step 1, step 2, step 3.
yeah, I'll do that. So this is how I configure. This is our step 1. Step 2, step 3. Now I'll go for step 4. So step number 4, crypto IKv2 profile. I'll create a profile and give a name as a R1 profile. Okay. And here I'll say, now in IKv2, there are few repetition things initially they configured. They have sorted this thing, this configuration in a flex VPN. There is something called as a flex VPN. I don't know if you guys have heard about it. Okay. So here I have to again say authentication local is pre-shared key, and authentication remote is pre-shared key. I'm writing in a short form, right? Again, I'll say my key ring is local with the name KR. My key ring name is KR. Right, and here I have to say match identity remote address. My public IP 200.1.1.10 with the subnet mask as a 24. So I can give 32. 32 means a particular host IP. So let me create this profile. Done. Now, this was my step number 4. Step number 4. Now, step number 5, I'll complete. So in a step number 5, we'll create a transform set. So crypto IPsec transform set as a T set I'll give with ESP. You can go with AES, ESP with the SHA HMAC. Okay. Yep, let's go with SHA HMAC itself. So this is our step number 5. Phase 2 tunnel we created. Exit. Now, step number 6. Step number 6 is about creating a IPsec profile. So here you have to say crypto IPsec profile and write a name IPsec. I'll give a name IPsec profile. And here I have to say set transform set. What was my transform set name? tset. Again, I have to say set IKV2. Okay, IKV2 profile. So what was my IKV2 profile name? IKV2 profile name was R1 Pro. So make it here, right? And say exit. So 6th number step, I'll quickly copy it, paste it here. Done. Hope I'm not getting any error. And 7th step and 8th number step. 7th number step and the 8th number step, I'll include it here. I'll go to a tunnel interface. Tunnel interface number was 1. I'll say tunnel protection. Tunnel protection. To avoid a spelling mistakes and all, write a short form. Okay. IPsec profile. And my profile of IPsec name is IPsec_pro. Now here I would say tunnel mode IPsec IPv4. Okay, IPv4. This command basically creates an SVTI, guys. Okay. Now, guys, there are two things. If I use ESP protocol, it will encrypt the entire traffic. Okay. So if you guys want to see with the AH
There's
protocol
a
and all,
spelling
that
mistake.
uh,
Second line, tunnel.
so I need to say, no, that
Second
is
line,
fine. Interpret.
tunnel.
Oh, yeah. Okay. Okay. So tunnel protection interface tunnel will go with, okay. So two things were missing, guys. Okay. So here, yep, now it is correct. See, now I'm getting ISACAMP is on, but I see my EIGRP neighborship has gone. The reason IPsec has, EIGRP neighborship has gone because IPsec is encrypting a packet over here. Now what we'll do is, this is our step number 7 and 8. 7 and 8. Now I'll make a mirror entry. Mirror entry in the sense I'll make a copy of these steps. And here I'll make a changes. Now, guys, if you want to give only one encryption or two encryption methods, it's up to you. If you want to remove any hashing algorithm, if you want to remove any Diffie-Hellman, it's up to you. It's up to you. Okay. So you can create it this way with the minimal algorithms that you want. These names and all are locally significant, guys. It does not have anything to do with your other site router. Okay. So you can change the IP or configuration wise if you want to leave it same, it's up to you. So the peer would be R1, destination IP would be 100. My local IP would be 3 and remote pre-shared key would be 1, right? And here I would go with now these names, it's up to you guys. Okay, I'm not changing any names over here. Let it be same. And all these steps, yeah, let it be as it is, right? Everything looks good. So I'll keep cross-checking. Minimum 2 algorithms I have kept it. And here I have 100 and here I have, okay. So everything looks good. I'll take all this. I'll put it on R3. Now our tunnel has gone down as of now. Okay, so I'll go to a configure terminal, press all the configurations. ISACAMP is on, tunnel is up, our EIGRP has come up. Now, since EIGRP has come up, your tunnel is up. Now, if you want to verify through CLI, as you guys were asking me today to do, okay. So if you say so IP, so crypto, not IP, so crypto IKv2SA, give this command, and here you can see. Okay, let me give the command. So here it says, this is my local IP. It uses UDP 500. This is my remote IP, uses UDP 500 as I told you for ISACAMP. Status of tunnel is ready. It actually selected encryption as a 3 days first come first serve basis. PRF is like pseudo random function, guys. It's like by default your system has a hashing algorithm given. Though I have a different hashing algorithm, but yeah, it has taken as a PRF value as well. So transform set. I mean, we call it as a under the payload. So under the transform payload, you'll have the additional transform payload with SHA-1 again SHA over here. Then it has selected Defi element group 5 authentication as a pre-shared key, lifetime as this. Okay, so this was my phase 1 tunnel. Now if you want to check a phase 2 tunnel, so crypto IPsec SA. Now here I can see, okay, it's a tunnel interface 1. I might have multiple tunnel interfaces, so this is about tunnel interface 1, where this is my local public IP address and this is my the destination public IP. Right. I can see total 28 packets encapsulated, encrypted, and digested, means hash value added. I received 29 packets till now. I verified, decrypted, and decapsulated. So while sending a packet, always it does a encapsulation, then encryption, then hash value gets added. But while receiving a packet, it verifies, hash value, then does a decryption, then does a decapsulation. So this way you guys can verify ESP protocol has been used for phase 2 tunnel. So it has taken 1 hour. So 3600 seconds taken for the phase 2 tunnel to rekey for phase 2. It is in a tunnel mode. These are the protocols and the algorithms used under the transform set. And the status is active here. So these are the status that you guys can check. Now, if I capture a packet here, oh, I have already done a capturing here, guys. So if you see here all the details in IKv2, as I told you, 4 packets will be exchanged. Okay, so here, okay, IKSA init. So I have an IKSA init, IK auth, right? IKSA init, initiator, responder, IK auth, initiator and responder. So total 4 message exchanges I have here, and it comes under the ISACAMP packet. Under the first, again, we have the same parameters. It is IKv2. It has a security association payload, and it has a proposal payload, and it has, say, multiple payloads over here. Now, if you guys imagine how many transform payload are there, total 8. But if I count how many it should be, if I count as per my R1, So 1, 2, 3, 4, 5, 6, right. And I have 7, 8, and 9. But we had a Shah, we had this one as a repeated one, right? So let's see. So these are the total proposals. Okay, IKSA in it, I can see. Now, on the responder side, if you see how many proposal payloads, transform payloads we have, 1, 2, we have only 4 here. So that's a agree packet. It agreed upon one encryption, one hashing, right? It agreed upon one Diffie-Hellman, and it agreed upon a one. I mean, there is one PRF as well. PRF is nothing but it's a default algorithm taken. So if you see here, this encryption method was agreed. And wherever you see pseudo random function PRF, it means it's taken default. So basically, I was supposed to get 3 algorithms, 3 transform payload as a result, but I'm getting 4. So here I was supposed to get uh, one encryption, one hashing, one Diffie-Hellman, but I see here 4. The reason why it is showing 4 is transform set 4. One pseudo random function has taken, the default hashing value has taken, right? So this is how you check the packets. Now, I'm not going to deal all the packets over here, guys. Now, that is like if you want more explanation, if you want to learn something new, you guys can follow our, modules. You can follow our curriculum. You can get an enrollment and all, where I'll show you in depth about all this informations. Right. So this was overall our GRE tunnel, guys, like how it works. If you need a notepad, I'll be sharing here. Guys, download it. So today we completed our VPN part, guys, and next week I'm going to start Palo Alto Firewall. Those who are interested with Palo Alto Firewall, even I'll show you an access to a physical hardware of your Palo Alto Firewall. So those who are interested, they can follow the classes. Okay.
Sir,
Yep. Tell me.
but we didn't check how to check them on the router.
I checked it right now on a router only, right? I checked on a router. See? What is this command? What is this? Crypto IPsec, crypto IKv2. I checked it through CLI as well, right?
Sorry, sir. Sorry, I was driving. Sorry.
Mhm. I have done it, guys. Okay. I'll see you guys in the next week with the next new classes. Till then, take care.
So, okay, sir, I sent you some pictures about the issue that I told you I'm facing
Okay,
yesterday.
I'll check it out and I'll revert you back. Okay.
Okay.